Let's take a look at the reaction between hydrogen and chlorine. So a hydrogen atom has one electron, and to become stable it needs to gain an electron, so that there's 2 electrons in that first shell to make it full. A chlorine atom has 17 electrons, and to become stable it needs to gain 1 electron. So what happens now? We have 2 elements that need to gain electrons to become stable, so there can't be any transferring of electrons. Are we stuck? No, we're not. Rather than transferring electrons like we saw in ionic bonding, electrons are being shared. This is covalent bonding and results in the formation of molecules. A covalent bond consists of a shared pair of electrons, and it can be represented by a single line as shown in these examples. Let's take a look at another example. It's probably a little bit more complicated. Oxygen is in group 6 of the periodic table. So how many electrons does an oxygen atom have in its outer shell? Well, it's in group 6, so that suggests that it has 6 electrons in its outer shell. So each oxygen atom needs 2 electrons to become stable, with a full outer shell of 8 electrons, like that of a neon atom, which is the nearest noble gas. An oxygen molecule therefore has 2 atoms sharing a total of 4 electrons. That's 2 pairs, so this is drawn as a double bond or 2 lines. The molecules described so far are described as simple covalent molecules, because they share electrons to form small, neat molecules. But in some covalent compounds, the atoms can be bonded together to form a large network of atoms. This is known as a giant covalent structure, otherwise known as a macromolecule. Let's take a look at an example of a macromolecule, silicon dioxide. When silicon reacts with oxygen, the silicon atom is too big to share 2 electrons with each oxygen atom. It must share one of its outer electrons with each of 4 oxygen atoms and receive a share of 1 electron from each oxygen in return. The oxygen atoms each need a share of 2 electrons to have a noble gas configuration, so an oxygen atom reacts with 2 silicon atoms. This links all the atoms together in a network called a giant structure or macromolecule. The diagram shows part of the repeating structure. Remember, not all the electrons and atoms are shown in a macromolecule. And some more examples of giant covalent structures: graphite and diamond. These are both made of carbon.